So now we're going to go ahead and try to solve for all the interacting forces at joint C. So again, we're going to create the free body diagram at joint C. So this is all of the different lines that go and touch joint C itself. So back from our moments, we have the reaction force at pin C in the y direction, which is 775. Then pulling out the red, we're going to get the force of member BC. We're going to assume tension, so pulling away, and we're going to have to calculate that. So we have force of member BC, and that's in the x direction just to keep things organized for ourselves. Then we're going to pull out the green, and we're going to look at this force of member EC. Now force of member EC is a moment, or CE, it is a moment, a vector that is going to have two different component vectors. It's going to have the force of CE in the y direction and the force of EC in the x direction. Those two composite vectors create that hypotenuse of that right triangle, the force of CE, that entire member. So if you take force of ECX plus force of ECY, you put those, if you walk to the left and then walk forward and then turn, you'll get that composite one. So it's the two legs of the triangle to get the other one. So what we're looking at is the force of all sum in the y direction is equal 0. So force of CEY is 775 because the force at reaction force at pin C in the y direction was 775 up. So that is 775 down. So that means it's applying compression. It's going down to that joint C. So then we're looking at that angle. We've got that right triangle. We got to know what angle that is. Again, from joint A, we have a 45, 45, 90 triangle because the two legs are equal. We have 3 by 3 are the two legs. Two legs are equal. You got 45-degree angle. So the sine of 45 is equal to opposite over hypotenuse, or the force of CE. Force of the member CE that's there. Then to go and calculate for the force of EC in the x direction, we're going to take the tangent. Tangent's equal to the opposite, 775, which is the force of CE in the y direction, over the force of EC in the x, which is that adjacent to that 45-degree angle. Pulling out our calculator and trying to solve those, we have got 775 times or divided by the sine of 45 gives us the force of CE. So the force of member CE is 1096. That again is going to be in compression due to the fact that the force of CEY was going down. And then when we got to go ahead and calculate the force of ECX, 7075 divided by that tangent of 45, which gives us 7075, which proves what we have done in geometry before. 45, 45, 90 gives us two legs that are equal. So now the sum of all the forces in the x direction needs to equal 0. We know the force of ECX is 775 applying compression, so it's going to the right. That means the force of BCX needs to be 775 going to the left, so pulling away from that joint C, so it is applying tension itself. So solving a right triangle, just like we've done in or going to do in geometry, and then just filling our information into our bigger chart, we can see now that we have got, 3 still unknowns that we got to go and solve for, and we'll work for those next, but now we've got enough information to go and solve for those top 2 joints.